In 712, they talk about a cube drop experiment. The objective is to guide you in comparing and predicting and actually getting results from an experiment with equally like outcomes. Mental math and reflexes. The fractions below, I want you to tell me how to write them as decimals. So I want you to be thinking about them in your head, and hopefully you're coming up with the right answer. So we write it like it said. 2/10, the first place after the decimal is the tenth spot, so it should be written 0.2. 50 hundredths, if we're writing exactly as it's written, it would be 0.50. 24 hundredths should be written, 24 hundredths should be written just like it says, 24 over 100. And 60 hundredths, it should be written 60 over 100. Notice I didn't say 60 thousandths, or that would have been 1,000 on the bottom. It's 60 hundredths, so 100's on the bottom. So how do we write 8 hundredths as a decimal? 0.08. How do we write 72 thousandths as a decimal? 0.072. How do you write as a fraction 3? Notice it's not in the first place, it's in the second one, so it's in the hundredths place. 3 hundredths is written exactly as we say it again, 3 over 100. And 29 thousandths, we write it as 29 over 1,000. 7 and 6 thousandths, 7 being the whole number, that would remain large, and our decimal point would be 0.006. Notice how in thousandths there's 3 zeros, so we know that that 6 needs to go in that third or last place. 32 and 1/100th, well, 32 is a whole number, so that stays large. Then comes our decimal point, 2 zeros, so the 1 goes down in that second 0 spot. 1 and 9/10 is 1 is the whole number, and then 9 over 10ths as our fraction. And 6 and 5/10 is written as 6 is a whole number, and the fraction is 5/10. 712 is going to be in your math journal, and it's page 213. Expected spinor results. So they're showing you a colored circle that they're considering to be a spinor, and they're saying to you, if it is spun 24 times, how many times do you expect it to land on each color? Well, the first thing I would do is I'd look and see, are my sections that it's cut into equal? Well, yellow and red and blue, green, blue, red, they're all the same size. They have exactly 2 sections, 1, 2, to every one of their rectangular type pieces. 1, 2, yep, they're equal. Okay, then I would look at, okay, red, blue, yellow, green. There is a total of 1, 2, 3, 4, 5, 6 similar pie pieces. If my total needs to be 24, then I need to figure out what each one of these pie pieces is worth. Well, 6 into 24 is 4, because 4 times 6 is 24. So each one of these would be worth the number 4. Again, my total is 24. They gave you that number. So I got to assign each pie piece or section a number that it's worth. And if you look, if I go 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, plus 4 is 20, plus 4 is 24, that is what my total is supposed to be. Next it says, well, you got the color red. How many expected number in 24 spins would I expect it to land on red? Well, here's a red one, and it says that red one is worth 4. But here's another red one. So how many times will it land on one of these red pieces? A possibility of 8 times. A blue. Well, there's one blue, and that says that's worth 4. And another blue, so that's worth, again, another total of 8 times. Yellow. There's only one yellow, so that box is telling me that it's only worth 4. And green. There is one green also here, so that is worth 4. To check to see if you did it right, all you have to do is add 8 plus 8 is 16, plus 4 is 20, plus 4 is 24, and again, that is what my total should be. So explain how you determine the expected number of times the spinner would land on each color. Go ahead and try to put in your own words what I just described to you there. Next, as I'm quickly erasing, I'm going to scroll the paper upward, and I don't want any of this left over for you to have to look at. And it says, if a 6-sided die was rolled 12 times, how many times do you expect it to roll it on an odd number? Well, I'd first write down my odd numbers. My odd numbers on a die would be the numbers 1, 3, and 5. So if I was only rolling it 6 times, it would be 3 out of 6. But since I'm rolling it the required 12 times, I would need to double that. So I would consider rolling it 6 times out of 12. A number less than 4. Well, here again, what are my numbers less than 4? The number 1, the number 2, and the number 3. So how many times would I expect that to roll out of 12 times? Well, it's 3 numbers, similar to the 3 numbers that's up above. So again, my chances would be to roll it 6 out of 12 times. A number 6. Well, there is only one number 6 on a die. So if I rolled it 6 times, I'd get it once. But again, remembering I got to roll it 12 times, my chances would double, which would be 2. A square number. In order to figure out what a square number is, I could tell you, and I could also tell you what a triangular number is and a prime number, but I want you to go look those words up back in the glossary in your student reference book. Check and see what that's telling you about each one of these next 3. If you can't figure it out, I want you to come back to the table with me and I'll help you further with those problems. On Math Journal page 216, I want you to solve the problems that involve ordering numbers, identifying place value, determining the values of digits, and reading and writing whole numbers. Again, that's page 216 in your Math Journal. Then go up to the Math Journal answer key and correct them. And the final thing to do for 712 is the study link. What are your chances? Please finish this and do the practice on the bottom and turn it in to me so that I can correct it and let you know how well you've mastered these skills.